Dear students, in this video we are going to learn about some concepts of virtual memory like allocation of frames, thrashing and working set model. Allocation of frames. Each process needs minimum number of frames for its execution to be possible in the main memory. Two major allocation schemes are used in the allocation of frames. One is fixed allocation, another one is priority allocation. Under fixed allocation, equal allocation, proportionate allocation is there. Fixed allocation allocates each process equal number of frames. For example, if there are 100 frames and 5 processes, then fixed allocation strategy allocates 20 frames for each process. Under proportional allocation, each process will get a certain number of frames based on its size. For example, PI is the number of processes available in the system and SI is the size of the process PI. Capital S is equal to sum of the sizes of the each process I. M is nothing but total number of frames available in the main memory. Then, according to the proportional allocation, the number of frames allocated for a process Pi, that is represented as AI, is equal to small si divided by S into M. This is the method used for allocation of frames for process Pi. For example, if the total number of frames available in the system is M equal to 62 and there are two processes are there in the system and the size of the first process is 10 and the size of the second process is 127. Then the number of frames allocated for the first process A1 is equal to 10 divided by 137 multiplied by the total number of frames available in the system, that is approximately 4. The number of frames allocated for the second process P2, that is A2, is equal to the size of the process A2, size of the process P2 127 divided by total size of the all two processes, that is 137 multiplied by 62, that is approximately 57 number of frames are allocated for process 2. Priority allocation uses priority of the process for allocating a frame. For example, when a high priority process requires a free frame, then a frame from the low priority process is taken and then it is allocated to a high priority process. In that way, the priority is used for allocation of the frames to a process. Global versus local replacement, local allocation. Under global replacement, a process will select a frame from any one of the free frames available across all the processes in the physical memory. So therefore, process execution can vary because of this strategy, but the system throughput will be improved. Whereas local replacement, each process selects frame only from its allocated frames only for page replacement, and because of this strategy more consistent process performance will be ensured, but there will be a possibility of underutilized memory because some of the frames which are not used in the processes will be left underutilized in the local replacement. Thrashing is a concept of process busy swapping pages in and out. If a process does not have enough pages, the page fault rate is very high. Page fault occurs to get page, then existing frame is replaced. But quickly the replaced frame is required back. This leads to low CPU utilization. OS increase the degree of multiprogramming because of low CPU utilization. So when degree of multiprogramming is increased, additional processes will be brought into the main memory, which increases the thrashing and hence more number of pages or page faults occurs. when we observe the effect of thrashing by increasing the degree of multiprogramming. Initially, when there are less number of processes in the main memory, CPU utilization will be more. As you increase the number of processes in the main memory, the CPU utilization keeps increasing to a certain limit. At one point of time, when the threshold limit is reached, even if you increase the number of processes in the main memory, the CPU utilization will not be improved. Rather, the CPU utilization will come down, because as you increase the number of processes in the main memory, the allocated number of frames per process gets reduced, which leads to more number of page faults. When page fault occurs, the page replacement needs to be carried out in the physical memory. This consumes time. So therefore, the CPU utilization will be reduced because of increasing the number of processes in the main memory after some threshold limit. Working set model. In this working set model, we are going to decide which pages are needed to be kept in the physical memory for references. This is determined based on a working set window W. W is nothing but the total number of pages referenced in the most recent time, that is delta. If delta is too small, it will not encompass entire locality of pages. If delta is too large, it will encompass several localities of pages. If delta is equal to infinity, it encompasses the entire program. So therefore, choosing the appropriate delta plays a very important role in working set model. So for example, if you consider a page reference string like this, and in a delta time t1, the number of frames which are referenced in this window period are 5, and the pages are referenced in this window are 1, 2, 5, 6 and 7. These are all the pages referenced in this window period. Coming to the second window period T2, the pages which are referenced in this window are 3 and 4 only. So therefore, in this T1 window, the frames 1, 2, 5, 6, 7 are required. In window T2, the frames 3 and 4 are required. So based on the availability of number of free frames in the physical memory, whichever pages are specified in the window 1 are stored during the time T1. Similarly, during the time T2, whichever pages are referenced in the window period T2 are stored in the frames in the physical memory. This helps in reducing the number of page faults generated while referencing the pages by the CPU. Here D is nothing but total demand frames across all the working set windows. If D is greater than M, where M is nothing but the number of frames available in the physical memory. If the total demand frames is greater than the available number of frames in the physical memory, this leads to thrashing. So when D is greater than M, the policy followed is then suspend one of the process or swap out one of the process from the physical memory so as to reduce the page faults and hence reduces the effect of thrashing. So this is the concept of working set model to reduce the number of page faults occurring in the physical memory, as well as to reduce the effect of thrashing. Thank you for watching this video.